welcome to the Inspiring Tech Leaders podcast with me, Dave Roberts. This is the podcast that talks with tech leaders from across the industry, exploring their insights, sharing their experiences, and offering valuable insight to technology professionals. The podcast also explores technology innovations and the evolving tech landscape, providing listeners with actionable guidance and inspiration. In today's podcast, I'm discussing vibe coding and how it's rapidly reshaping how organizations develop software. Vibe coding allows teams to instruct an AI in natural language to generate and sometimes execute code. It is attractive due to the speed, agility, and innovation it enables. But with innovation comes risk, and in this episode I will examine the key risks associated with vibe coding, and more importantly how tech leaders can mitigate those risks while maintaining control. I will also discuss governance frameworks, organizational boundaries, and best practices for secure adoption. By the end of this session, you will have a clear picture of what it takes to safely integrate vibe coding into your enterprise without exposing your organization to unnecessary risk. So vibe coding is fundamentally different from traditional software development. Instead of writing lines of code manually, developers or business users provide instructions in natural language. An AI agent can generate the required code and in some systems even deploy it in a controlled environment. The benefits are clear. Development cycles accelerate, backlogs are reduced, and prototyping becomes far faster. This approach also democratizes software creation across the organization, allowing business users and analysts to contribute directly. However, speed and efficiency cannot come at the expense of security, compliance, or governance. Tech leaders must ask themselves what potential blind spots exist and how they can be effectively managed. There are 5 primary risks that tech leaders need to consider. First, security vulnerabilities are a significant concern. AI-generated code can inadvertently introduce weaknesses. Libraries may be outdated or contain known vulnerabilities, and AI agents can hallucinate APIs or produce logic that is fundamentally insecure. For example, a Python script generated by AI might query a database without input validation, exposing the system to SQL injection attacks. Security cannot be assumed. Every AI-generated artifact must undergo rigorous review, scanning, and testing before deployment. Second, data leakage and privacy risks are prevalent. Prompts often contain sensitive information, including internal databases, customer data, or proprietary business logic. If these prompts are processed in environments that are not isolated or fully enterprise controlled, confidential data may be exposed or unintentionally used to train third-party AI models. This is particularly risky when using consumer-grade or cloud-based AI tools. Organizations need to implement strict data boundaries and prompt hygiene to protect intellectual property and personal information. Third, over-permissioned AI agents can be dangerous. Some AI systems can execute code autonomously, modifying infrastructure, deploying software, or interacting with databases. Without clearly defined execution boundaries, AI agents can introduce errors or misconfigurations into production systems, pull external code containing malware, or create cascading effects that are difficult to trace. Autonomy must always be balanced with oversight. Fourth, compliance and auditability gaps arise because AI-generated contributions often break traditional audit trails. Regulators and internal auditors will expect clear accountability, but AI wrote this code is not sufficient. Organizations risk compliance breaches if there is no record of who instructed the AI, no documented review or approval, or if AI-generated code bypasses standard change management processes. Establishing a clear chain of accountability is therefore essential. And the 5th risk is the erosion of engineering standards and skills, which is a real concern. Over-reliance on AI can weaken human expertise. Junior engineers may defer critical thinking to AI outputs, and coding standards and best practices can erode if AI code is not reviewed rigorously. The solution is to integrate AI responsibility into existing engineering culture, with mentorship, training, and human oversight. A fundamental step in risk mitigation is building a secure vibe coding architecture. AI-generated code should never run directly in production. It is critical to use sandboxed environments where code can be tested safely, to restrict network access, and to control external API calls. Enterprise models must be licensed and secured, and sensitive data should remain encrypted at all times. This approach functions as a digital quarantine, ensuring that code is fully validated before it touches live systems. Equally important is implementing human-in-the-loop controls. No matter how advanced AI becomes, human oversight is mandatory. Peer review or manager approval should be required before merging AI-generated code, treating AI like a junior developer that drafts, suggests, and prototypes, but never makes final decisions. Integrating AI outputs into standard change management workflow ensures compliance and auditability, so speed does not compromise security. Secure prompt engineering and data handling are also critical. Organizations must remove sensitive information from prompts, use templates that enforce secure coding patterns, and automate filters to prevent restricted or regulated data from entering AI systems. Policies should explicitly prohibit submitting personal data without anonymization. In addition, adopting guardrails and policy enforcement tools helps capture issues that may otherwise go unnoticed. AI-generated code should be scanned using static and dynamic analysis tools. AI-aware security platforms such as SonarQube for AI can identify vulnerabilities, unsafe dependencies, or logic errors. Continuous monitoring in production ensures any anomalies are detected even after human review. Skills, training, and culture change are also essential. Teams must be trained in AI security, prompt hygiene, and ethical coding practices. Developers should validate AI outputs rigorously, and mentorship programs should preserve core engineering skills while leveraging AI acceleration. Culture ensures that technical controls are consistently effective across the organization. In addition to these technical and process-based measures, organizations should implement practical, field-tested security controls. AI code review tools should examine every pull request. These tools can help catch SQL injection, exposed credentials, and broken authentication before code goes live, and when combined with human review, they provide multiple layers of protection. Rate limiting should be applied from day one, with a conservative starting point, such as 100 requests per hour per IP, to prevent bot attacks, database abuse, and excessive costs. Row-level security should be enabled in databases from the start to ensure that users can only access their own data. AI can generate policies, but human testing is critical. API keys should never be stored in code. Instead, tools such as Azure Key Vault or AWS Secrets Manager should be used, with keys rotated regularly. Invisible capture should be deployed on forms, registration, and login endpoints to block bots without disrupting legitimate users. HTTPS must be enforced on all endpoints to protect session tokens, passwords, and API keys. Every input should also be validated on both the front and back end, and dependencies should be updated regularly with security patches applied immediately. AI accelerates code creation, but security requires multiple layers such as AI writing, AI auditing, and human review, combined with monitoring and rate limiting. These practices can help prevent the vast majority of attacks and costly breaches. Strong governance ensures that AI is a control tool rather than a liability. Developers should align with recognized frameworks such as NIST AI risk management frameworks to identify and mitigate AI risks, ISO 23894 for guidance on AI governance, OWASP Top 10 for LLMs to focus on AI-specific security issues, and CIS benchmarks for AI and ML ops to provide operational guardrails. Organizational boundaries should be clearly defined. Usage should be limited to internal tools unless approved. Execution should never allow autonomous production deployment. Data must be carefully controlled to exclude personal or sensitive information in prompts, and only approved AI models should be used. Accountability must be assigned clearly to the roles such as AI product owner, AI risk officer, and engineering lead, with complete audit logs maintained of prompts, code generation, review, and deployment. So, to summarize, vibe coding drives innovation, but it carries significant risks. Mitigation requires sandbox environments, human oversight, secure prompt practices, AI auditing, and practical security controls. Strong governance frameworks and organizational boundaries are non-negotiable. Maintaining skills and fostering a culture of critical thinking ensures that these controls are effective. For senior technology leaders, the message is clear. Innovation must be balanced with security, oversight, and accountability. Well, that's all for today. Thanks for tuning in to the Inspiring Tech Leaders podcast. If you've enjoyed this episode, don't forget to subscribe, leave a review, and share it with your network. You can find more insights, show notes, and resources at www.inspiringtechleaders.com. Head over to the social media channels. You can find Inspiring Tech Leaders on X, Instagram, Inspo, and TikTok. Let me know your thoughts on vibe coding. Thanks for listening, and until next time, stay curious, stay connected, and keep pushing the boundaries of what's possible in tech.